Morning everyone, this week's work is looking at probability in more detail, so we'll be looking at calculating the probability of events not happening, relative frequency and estimating probability. So this week we're going to be introducing probability in decimal form. So the first thing we need to go back through is how do we define probability? Well, an event that has a probability of 1 is certain. On the other scale of that, the probability of an event having 0 is impossible, it definitely will not happen. So this is page 10 in your unit. The first thing I need you to do is copy this into your notebook. The probability of something not happening is 1, which is the total probability, minus the probability that it does. So the first example is we are told the probability of Jill winning a raffle is 0.02, and we're having to work out the probability she doesn't win. So that will be 1, which is your total, minus her probability of 0.02 to get you an answer of 0.98. Nice and straightforward. So relative frequency, what relative frequency is just a fancy name for describing probability that you get from experiments. So rolling a dice, flipping a coin, picking beans out of a bag, etc. So it's just another way of writing probability, either in fraction or decimal form. Now, estimating the probability of an event happening. This will be based on the number of times you plan or wish to carry an experiment out. And it is just simply the probability, so whether it be a half, a third, a fifth, 0.3, whatever the probability is, multiplied by the number of times you plan to do the experiment. So 50, 100, 200, 600, it will tell you in the question. So example 2 on page 10. So we are told a spinner is spun 20 times and the results are shown below. So we have a list of numbers. So from 1, 2, 3 and 4 obviously are the only numbers on the spinner because they are the only answers that we've got. So the first question, what is the relative frequency of getting a 4? So you count the number of 4s you have in that list, which is 6, and you write it as a fraction over 20. Now we know with probability, if you can simplify, do so. So 6 over 20 is simplified down to 3 over 10. So then part B, what is the relative frequency of not getting a 4? Well, if it's 3 over 10, it's a probability of getting a 4. It is that number subtracted from 1, which is 7 over 10. And part C, the experiment is repeated 60 times. Estimate the number of times you will get the number 1. So the first thing we need to do is we need to find what is the probability of getting 1. So count the number of 1s you have in your list. So it's 1, 2, 3, 4. So it's 4 out of 20. And again, we know it can simplify down to a fifth. So now we have our probability. We have the number of times we are doing the experiment and we must multiply those two together. So a fifth multiplied by 60. When you're multiplying by a fraction, just divide by the bottom number. 60 divided by 5 multiplied by 1 gets you an answer of 12. So you would estimate that if you were to continue this experiment 60 times, you would get the number 1 12 times. Okay, so continuing on page 11, just another 2 examples. So we are told a spinner has 4 sections A, B, C and D. The probabilities of landing on each are shown in the table. So A is 0.1, B is 0.3, C there's nothing there, and D is 0.4. What is the probability of getting a C? Well, we know these 4 have to add to 1. So to find the missing 1, you add your 3 other probabilities up and then you will subtract it from 1. So it's 1 minus 0.1 plus 0.3 plus 0.4, which gets you an answer of 0.2. And I would always go back and just fill it into the table as well. B, what is the probability of not getting a D? Well, the probability or the chance of getting D is 0.4. So we subtract that from 1 to find the probability of not getting it is 0.6. Part C, what is the probability of getting an E? Well, there are no E's in the table, so there's a 0 chance of getting it. So we would put 0. This stage we do not use the word impossible to describe it because it hasn't asked you. It has asked you what is the probability, so we'll put 0 down. The spinner is spun 200 times. Estimate the number of times you'll expect it to land on B. Well, we know the probability of B is 0.3. And we know that we plan on carrying this out 200 times. If we multiply those two together, you would expect to get the letter B 60 times. And it's just simply 0.3 times 200. In our example 4, a biased dice. Biased means it's not fair. Is thrown. The probability that this dice will land on each of the numbers from 1 to 6 is given in the table. So we've got 1 is X. So obviously we're going to be finding out what that is. 2 is 0.25. 3 is 0.3. 4, 0.1. 5, 0.2. 6, 0.05. The reason why it is biased or not fair, because they should have roughly the same chance of landing on each of those numbers. Work out the probability of X, and again, we know they should equal 1. So what we'll do is we'll add up the probabilities we've been given, and we'll take them away from 1. We'll quickly just jot those down. And that is 0.65, which gets you an answer of 0.1. And again, I'll just put it into the table as well. So the dice is thrown 80 times. Estimate the number of times you would expect it to land on the number 6. Well, we know the probability is 0.05. We know the number of times you plan to do the experiment is 80. And you just multiply those together. 4. Part C. Calculate the probability it will land on a higher number than 4. That means it's a 5 or a 6. So we add those two probabilities together because we need both of them. 0.25. And then finally, what is the probability of not landing on a 3? Well, we know the probability of getting a 3 is 0.3. So we simply subtract that from 1. 0.7. So what I need you to do is to complete these examples in your books, and then I'm going to set you a few questions that I need you to be working on throughout the rest of this week.